All right, this is going over the 2014 number 1 for AB. So we have grass clippings that are placed in a bin where they decompose. They're in there from time equals 0 to 30. The amount of grass clippings remain in the bin is modeled by this, where A at T is in pounds and T is measured in days. A, find the average rate of change. So the average rate of change is the slope. So the average rate of change would be just the slope between the endpoint and the beginning. So taking that, you're going to figure out what A of 30 is by plugging in 30. And then plugging in T equals 0. And this works out to be negative 0.197. And this is a slope, so it's going to be, A was in terms of, I'm trying to find it, pounds, and time was in terms of days, so this is going to be pounds per day. Part B. Find the value of A prime of 15. So this right here is the instantaneous rate of change. So A prime, which is the same thing as dA dt, and you're going to be evaluating at that time equals 15. Because this is a calculator problem, you can completely do this in your calculator, but let's just remember what the derivative would be. So this is the derivative of something like a to the x, and when you take the derivative of something like a to the x, it's going to be a to the x times natural log of a. So this derivative would be 6.687. Then we'll have the exponential function times the natural log of the base. And this works out to be negative 0.164. It asks us to interpret this, so we need to write a sentence explaining it. It says the amount of grass clippings, the amount of grass clippings is decreasing at a rate of 0.164 pounds per day at time equals 15. So when you're reading the problem, make sure you do exactly what it asks you to do. If it asks you to include the units, make sure you include the units. It will be a point. If it asks you to describe what is happening, make sure you interpret what is happening here by writing a sentence explaining what is happening. C. Part C says, find the time for which the amount of grass clippings in the bin is equal to the average amount of grass clippings in the bin over the time interval. So we want to know the first time the amount of grass clippings, the amount of grass clipping is given by A of T. The average amount of grass clippings is given by the integral from 0 to 30 of the amount divided by the interval length. And that's got to be equal to A of T. Putting that into our calculator, we're going to get the left side is 2.7526. And that's got to equal to the exponential function. So we can divide both sides by the 6.687. And we're left with the left side being 0.4116. taking the natural log of both sides. Remember, when you take the natural log, the power can come out in front. So we know t works out to be 12.41 days. And then the last part of the problem is part D. It asks for a time bigger than 0, the linear approximation at time equals 30 is a better model for the amount of grass clippings remaining in the bin. Use LT to predict the time at which there will be 0.5 pounds of grass remaining in the bin. Okay, so let's think about what the linear approximation would be. So remember, you have a point, and that would be our initial condition. So we know at time 0. So in part D, we're going to do a linear approximation starting at time equals 30 to predict how much there is when there's 0.5 pounds of grass remaining in the bin. Okay, so first thing, looking at how much there is at time 30, you're going to look at A sub 30, and that works out to be 0.78298. And then we're also going to look for the derivative at 30. Both of those can be found in your calculator. Just a quick calculation. So now we're going to do our linear approximation. So our linear approximation is going to be where we started, which would be our initial condition, plus the derivative, and then t minus 30. So we want to know when the L of t is 0.5. So we're left solving this equation. And that gives us t equals 35.054. So how did the points get allocated? The first point comes from part A, having the unit and the answers. The answer and the units. Part B, there are 2 points, one from finding the derivative and one for doing interpretation. Part C is worth 2 points, one for finding the integral, the average rate, and then one for finding the value of t. And part D is worth 4 points, one for the expression for L at t, and I'm guessing they probably gave you 1 point for getting those correct and one for writing the correct equation correct, one for knowing that you needed L of t to be 0.5, and one for getting the correct answer.